The morning of April 23, 1944, over the rail yards of Hamm, Germany, Captain Robert Johnson pulls his P-47 Thunderbolt into a shallow dive, the airframe shuddering under the weight of 2,000 pounds of bombs strapped beneath the wings. Behind him, 8 Browning .50 caliber machine guns, each loaded with 400 rounds, wait in their wing mounts. The radio crackles with broken German transmissions. Luftwaffe controllers are calling intercepts. Fokker-Wulf 190 pilots climbing fast from the east. Johnson glances at his fuel gauge, calculates the math in his head, and knows the truth that German intelligence still refuses to believe. The Americans have built a fighter that carries more ordnance than most light bombers, flies higher than most interceptors, and still has enough fuel to make it home across 300 miles of occupied Europe. This was not supposed to be possible. German engineering doctrine, refined through years of aerial combat over Spain and Poland and France, held that fighters must be light, agile, and specialized. You built an interceptor to kill bombers. You built a ground attack plane to destroy tanks. You did not combine them. The laws of physics, the Luftwaffe's technical staff believed, simply would not allow it. A heavy fighter laden with bombs would be a sitting target for any competent pilot in a nimble 109 or 190. Yet here they were, spring of 1944, and the reports flooding into Luftwaffe intelligence offices told a different story. American Thunderbolts were not just escorting bombers anymore. They were obliterating rail lines, strafing airfields, destroying convoys, and when challenged in the air, they were winning. The cognitive dissonance was profound. How could a single aircraft, weighing nearly 8 tons fully loaded, outfight and outlast purpose-built German fighters? If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand what the P-47 Thunderbolt represented, you must first understand what it was not. It was not elegant. When the first prototypes rolled out of Republic Aviation's factory in Farmingdale, Long Island, in 1941, even American test pilots laughed. The fuselage was barrel-shaped, almost comically wide, housing the enormous Pratt & Whitney R2800 double wasp radial engine, 18 cylinders arranged in 2 rows, producing over 2,000 horsepower. The aircraft weighed 7 tons empty. Fully loaded with fuel, ammunition, and ordnance, it could exceed 15,000 pounds. For comparison, the British Supermarine Spitfire, the gold standard of fighter design at the time, weighed less than 6,000 pounds fully loaded. The German Messerschmitt Bf 109 weighed just over 7,000. The Thunderbolt was a different species entirely. Alexander Kartveli, the Georgian-born engineer who designed it, was not trying to build a dogfighter. He was trying to build a survivor. Kartveli had watched the early air battles over Europe with a cold, analytical eye. He saw that most fighters were shot down not in turning engagements, but in ambushes. A pilot who never saw his attacker had no chance, no matter how agile his aircraft. Kartveli's philosophy was simple. Give the pilot armor, give him an engine that could absorb punishment, give him altitude performance so he could see the enemy first, and give him enough firepower to end a fight in a single pass. The result was an aircraft that violated every conventional principle of fighter design and yet worked brilliantly because it ignored the wrong principles. The heart of the Thunderbolt's capability was not its guns or its bomb racks. It was the turbo supercharger system. This was not a simple bolt-on modification. It was an engineering marvel, a labyrinth of ducting that ran the entire length of the fuselage, channeling exhaust gases from the engine to spin a turbine that compressed incoming air, forcing it into the cylinders at high altitude, where the atmosphere was thin. This system allowed the R2800 engine to produce full power at 25,000 feet, an altitude where most other fighters gasped for air. German pilots, accustomed to the superior high-altitude performance of their own aircraft, were stunned to discover that the Thunderbolt could not only reach their altitude, but could accelerate and climb while doing so. It rewrote the tactical calculations of air combat. But the supercharger was also the reason the Thunderbolt was so large. The ducting alone weighed hundreds of pounds. The system was temperamental, prone to overheating, and required constant maintenance. Early models suffered chronic failures. Pilots returning from missions over France in the spring of 1943 reported turbo failures at rates exceeding 15%. Republic's engineers worked around the clock, redesigning exhaust manifolds, improving seals, rerouting coolant lines. By late 1943, the system was reliable, and once it was reliable, the Thunderbolt became nearly unstoppable. The armament was equally uncompromising. 8 Browning M, 2 50-caliber machine guns, 4 in each wing. Each gun fired at a rate of 800 rounds per minute, a 2-second burst delivered over 200 rounds. The kinetic energy was devastating. 50-caliber rounds could punch through the engine block of a truck, shred the wing spar of a fighter, or ignite the fuel tanks of a locomotive. American pilots called it a flying buzzsaw. The guns were arranged in the wings, outboard of the propeller arc, which meant there was no synchronization gear to fail. They simply fired, all 8 at once, converging their fire at a point 300 yards ahead of the aircraft. Anything in that cone of fire disintegrated. The bomb load was the final piece. The P-47D, the most common variant, could carry 2,500 pounds of ordnance. Typically, this meant 2 1,000-pound bombs and a 500-pound bomb, or 3 500-pounders and a set of 5-inch high-velocity rockets. The bombs were mounted on underwing pylons and a centerline fuselage rack. The pylons were stressed to handle the weight and the aerodynamic loads of high-speed flight. Early tests revealed that dropping bombs at speeds above 400 miles per hour could cause the bombs to tumble and miss their targets by hundreds of yards. Republic engineers developed timed release mechanisms and stabilizing fins. By 1944, Thunderbolt pilots could dive at terminal velocity, release ordnance with precision, and pull out without exceeding the structural limits of the airframe. This combination, guns and bombs on a single platform, was revolutionary. Most air forces separated these roles. The Luftwaffe used Stukas for ground attack and 109s for air superiority. The Royal Air Force used Typhoons for ground attack and Spitfires for interception. The Americans, constrained by logistics and the vast distances of the European theatre, needed versatility. They needed an aircraft that could escort bombers deep into Germany, then peel off and strafe a rail yard on the way home. The Thunderbolt was that aircraft. But its versatility came at a cost. Fuel consumption. The R2800 engine, producing over 2,000 horsepower, burned fuel at a prodigious rate. At combat power, the Thunderbolt consumed nearly 150 gallons per hour. That gave it roughly 2.5 hours of flight time, enough to reach the German border from England, but not enough to escort bombers to Berlin. To extend its range, engineers developed external drop tanks. These were pressed steel or even paper and resin tanks, mounted under the fuselage or wings, holding an additional 100 to 200 gallons. The tanks were expendable. Once empty, pilots jettisoned them before entering combat. By mid-1944, with the introduction of the 108-gallon paper drop tank, the Thunderbolt's combat radius extended to nearly 500 miles. Suddenly, no target in occupied Europe was safe. The logistics of keeping the Thunderbolt flying were staggering. Each aircraft required constant maintenance. The R2800 engine, robust as it was, needed an overhaul every 200 hours of flight time. The supercharger ducting had to be inspected for cracks after every mission. The 50-caliber guns had to be cleaned, oiled, and test-fired. Ammunition belts had to be loaded by hand, each round checked for defects. Bombs had to be transported from depots, often under enemy fire, and mounted on the aircraft by ground crews working in freezing rain or blistering heat. The fuel, high-octane aviation gasoline, had to be filtered multiple times to prevent contamination. A single grain of sand in the fuel system could seize the engine at 20,000 feet. The men who maintained the Thunderbolts were largely invisible to history. They worked 18-hour shifts, slept under the wings, and lived in tents on muddy airstrips carved out of French farmland. Many were barely out of high school. They learned to rebuild engines with improvised tools, to patch bullet holes with sheet metal scavenged from wrecked aircraft, to keep the machines flying through sheer determination. One crew chief, interviewed decades later, said that he could tell the condition of an engine just by listening to it start. A healthy R2800 had a deep, rhythmic growl. A sick one coughed and sputtered. He said he never lost a pilot to mechanical failure, and he said it with the pride of a man who knew he had saved lives with his hands. The Thunderbolt entered combat over Europe in the spring of 1943. The 8th Air Force, stationed in England, was suffering catastrophic losses. Daylight bombing raids over Germany were being torn apart by Luftwaffe fighters. The bombers, B-17 Flying Fortresses and B-24 Liberators, flew in tight formations for mutual defense, but without fighter escort, they were slaughtered. The P-38 Lightning, the Americans' first long-range fighter, had the range but lacked the performance at high altitude. The P-51 Mustang, which would later become famous, was still in development. The Thunderbolt was rushed into service, and the early results were mixed. The first missions revealed the aircraft's weaknesses. It was heavy. In a turning fight at low altitude, a Focke-Wulf 190 could outturn it easily. It was slow to accelerate. If a pilot was caught at low speed and low altitude, he was dead. The early pilots, trained in the tactics of World War I dogfighting, tried to fight the Thunderbolt like a Spitfire. They lost. Badly. The kill-to-loss ratio in the first 3 months was barely 1-to-1. The aircraft was blamed. Pilots called it the Jug, short for Juggernaut, but the nickname was not affectionate. It was a resignation. They were flying a machine they did not yet understand. Then, the doctrine changed. A handful of pilots, men like Hub Zemke and Francis Gabreski and Robert Johnson, began to figure out how to fight in a Thunderbolt. The key was altitude. The Thunderbolt could climb to 30,000 feet and cruise there comfortably, higher than almost any German fighter could operate effectively. From that altitude, it could dive. And in a dive, the Thunderbolt was faster than anything in the sky. Pilots began using slashing attacks. Dive from above, fire a burst, keep diving, and extend away. Never turn. Never slow down. Use speed and altitude as weapons. The Germans called these tactics boom and zoom. The Americans called them winning. The transformation was rapid. By the summer of 1943, the Thunderbolt squadrons were racking up kills. The 56th Fighter Group, Zemke's Wolfpack, became legendary. They developed the Finger 4 formation, 4 aircraft flying in a staggered line, each pilot covering the others. They trained relentlessly, practicing high-speed gunnery and coordinated attacks. They studied the Luftwaffe's tactics, learned to anticipate the German fighters' moves, and exploited every weakness. By the end of 1943, the 56th Fighter Group had the highest kill ratio in the 8th Air Force. The Jug had become a legend, but air superiority was only half the mission. In early 1944, as the Allies prepared for the invasion of Normandy, the Thunderbolt was tasked with a new role: ground attack. The Luftwaffe was being bled white over Germany, but the Wehrmacht still controlled vast territories. Rail lines carried reinforcements, convoys moved supplies, airfields launched interceptors. The Allies needed to strangle German logistics, and the Thunderbolt was the perfect weapon. It could carry bombs. It could strafe with devastating firepower, and it could survive the intense anti-aircraft fire that surrounded every strategic target. The first large-scale ground attack missions began in March 1944 as part of Operation Strangle. The objective was to destroy the rail network in northern France and Belgium, cutting the flow of German reinforcements before D-Day. Thunderbolts flew hundreds of sorties daily, bombing rail yards, strafing locomotives, and cratering tracks. The results were immediate. German logistics collapsed, fuel shipments stopped, ammunition convoys burned. Entire divisions were stranded without supplies. The Wehrmacht's field commanders sent frantic reports to Berlin, describing relentless attacks by American fighter bombers that appeared without warning, struck with precision, and vanished before interceptors could respond. The Luftwaffe tried to adapt. Anti-aircraft defences were reinforced. Flak batteries surrounded every rail yard and bridge. German intelligence officers pored over the wreckage, trying to understand how the Thunderbolts could carry so much ordnance and still fight. One captured Luftwaffe report, dated May 1944, describes the P-47 as an armoured ground attack aircraft with the performance of a high-altitude interceptor. The report concludes that such an aircraft should not be possible given known engineering constraints. The author speculates that the Americans have developed a new type of engine or have discovered a way to reduce weight without sacrificing strength. The truth, which the Germans never fully grasped, was simpler. The Americans had built the aircraft correctly from the start. On the morning of June 6, 1944, D-Day, the Thunderbolt proved its worth beyond any doubt. Over 2,000 sorties were flown in the first 24 hours. Thunderbolts bombed coastal defences, strafed German positions on the beaches, and destroyed reinforcements moving toward Normandy. The noise alone was overwhelming. Soldiers on the ground, both Allied and German, described the sky as a continuous roar of engines. One German officer, captured near Carentan, said that the Americans controlled the sky so completely that moving in daylight was suicide. He said his men dug foxholes and waited for darkness because the sound of a Thunderbolt's engine meant death was seconds away. The cost was heavy. Ground attack flying was the most dangerous mission in the air war. Pilots flew at low altitude, often below 1,000 feet, through walls of anti-aircraft fire. Tracer rounds arced up from every hedgerow. Machine guns rattled from farmhouses. Flak shells burst in black clouds, shredding wings and puncturing fuel tanks. Casualty rates among ground attack pilots exceeded 30% in some squadrons. Men flew 4 or 5 missions a day, came back with aircraft so damaged they should not have been able to fly, and took off again the next morning. The survival rate was brutal, but they kept flying because the alternative was unthinkable. Without air support, the invasion would fail. The technical reality of what the Thunderbolt could carry was staggering when examined in detail. A standard load for a ground attack mission in the summer of 1944 consisted of 2 1,000-pound general-purpose bombs mounted on underwing pylons, plus a centerline rack carrying either a 500-pound bomb or 6 5-inch high-velocity aircraft rockets. The rockets, designated HVAR, were a recent innovation. Each rocket weighed 140 pounds and carried a warhead equivalent to a 5-inch naval shell. They were unguided, fired in salvos, and devastatingly effective against tanks, bunkers, and buildings. A Thunderbolt configured for maximum anti-armor work could carry 10 HVARs, 5 under each wing, plus its full ammunition load of over 3,000 rounds of 50 caliber. The total ordnance weight approached 3,000 pounds. Add fuel, pilot, and the aircraft itself, and you had a machine weighing over 8 tons trying to get airborne from a muddy strip in Normandy. Takeoff was the most dangerous moment. Pilots had to calculate weight, runway length, temperature, and wind with precision. Too heavy, and the aircraft would not rotate. Too much throttle too soon, and the torque from the massive propeller would pull the aircraft into a ground loop. The R2800 engine delivered so much power that inexperienced pilots often lost control on takeoff, veering off the runway and collapsing the landing gear. Training manuals emphasized a smooth, gradual application of power. Experienced pilots described it as feeling the aircraft's willingness to fly. You could sense, through the control stick and the rudder pedals, the moment when the Thunderbolt transitioned from a 10,000-pound truck to an aircraft. That moment, when the wheels lifted and the weight transferred to the wings, was described by many as the most exhilarating sensation in aviation. Once, airborne, the heavily laden Thunderbolt climbed slowly. A clean fighter, without external stores, could reach 10,000 feet in under 5 minutes. A fully loaded bomber variant took twice as long. This made the climb-out vulnerable. Luftwaffe tactics evolved to exploit this. German fighters would loiter near known Allied airfields, waiting for the moment when the Thunderbolts were heavy and slow. Several aircraft were lost this way in the early months of 1944. The solution was escort. One flight of Thunderbolts, configured as clean fighters, would orbit above the field while the ground attack flights climbed out. Once the bombers reached altitude and jettisoned their drop tanks, they could defend themselves. But those first 10 minutes were tense. The bombing itself required skill that went far beyond simply releasing ordnance. Dive bombing from a fighter was not like dropping bombs from a B-17 at 20,000 feet. The Thunderbolt pilot had to identify the target, roll inverted, pull through into a near-vertical dive, acquire the target in his gun sight, adjust for wind and airspeed, release at the precise moment to ensure the bombs would hit, and then pull out of the dive without exceeding the structural limits of the airframe or blacking out from G-forces. The entire process, from roll-in to pull-out, took less than 20 seconds, and during those 20 seconds, the pilot was a stationary target for every anti-aircraft gun within range. The dive angle mattered. Too shallow and the bombs would skip or tumble. Too steep and the pilot risked not pulling out in time. The standard attack profile was a 60-degree dive, initiated from 8,000 to 10,000 feet, with release at 3,000 feet. This gave the bombs enough time to stabilize and impact accurately while giving the pilot enough altitude to recover. But actual combat was never standard. Targets moved, weather obscured visibility, flak forced deviations, pilots adapted in real time, adjusting angles and release points based on instinct and experience. The best pilots could place a 1,000-pound bomb within 50 feet of a target from a screaming dive through exploding flak. It was not luck. It was math, physics, and ice-cold nerves. The rockets added another layer of complexity. HVARs were ballistic. Once fired, they flew in a straight line, subject to gravity and wind. They had no guidance system. Accuracy depended entirely on the pilot's ability to point the aircraft at the target and fire at the correct range. The effective range was roughly 1,000 yards. Closer was better, but closer also meant more exposure to ground fire. Pilots described rocket attacks as a game of chicken. You dove toward the target, centered it in your gun sight, waited until you could see individual vehicles or gun emplacements, and then fired a salvo and pulled out hard. The rockets left a trail of white smoke, and German gunners learned to track that smoke back to the aircraft. More than one Thunderbolt was shot down seconds after releasing its rockets. The firepower of the 50-caliber guns was equally precise and equally brutal. Each gun was harmonized to converge at a specific range, usually 300 yards. At that range, all 8 guns fired into a space roughly 6 feet across. The bullets were armor-piercing incendiary rounds, designed to penetrate metal and ignite fuel. A 2-second burst delivered enough kinetic energy to destroy a locomotive, flip a truck, or saw the wing off a fighter. But the guns had to be used carefully. Ammunition was limited. 3,000 rounds sounds like a lot, but at a combined rate of fire exceeding 6,000 rounds per minute, a pilot could empty all 8 guns in 30 seconds of continuous firing. Discipline was essential. Short bursts, aimed fire, no spray and pray. Ground crews reloaded the guns by hand after every mission. Each belt of 50-caliber ammunition weighed over 60 pounds. Loading all 8 guns meant handling nearly 500 pounds of ammunition, threading it through feed mechanisms, checking for jams, and ensuring the belts fed smoothly. It was exhausting work, done in all weather, often under the threat of German air raids. The ground crews took pride in their speed. The fastest teams could rearm and refuel a Thunderbolt in under 20 minutes. That speed kept the aircraft in the air. On D-Day, some aircraft flew 5 missions in a single day, returning only long enough to refuel, rearm, and let the pilot grab a sandwich before launching again. The fuel situation was a constant calculation. Every pound of bombs and ammunition reduced the fuel load the aircraft could carry. Every minute of combat burned fuel at maximum rate. Pilots had to balance mission requirements against survival. Running out of fuel over occupied France meant bailing out or attempting a forced landing, both of which often ended in capture or death. The ferry tanks helped, but they were not a perfect solution. The paper tanks in particular were fragile. They leaked. They sometimes failed to feed properly, leaving the pilot with less fuel than expected. More than one Thunderbolt ditched in the English Channel because the drop tank malfunctioned. Yet despite all these challenges, the Thunderbolt succeeded. The statistics tell part of the story. Between D-Day and the end of the war, P-47 seconds flew over 546,000 combat sorties in the European theatre. They destroyed over 7,000 aircraft in the air and on the ground. They obliterated 86,000 railway cars, 9,000 locomotives, 6,000 armoured vehicles, and 68,000 trucks. They dropped over 132,000 tons of bombs. These are not estimates. These are documented, verified numbers compiled from mission reports, gun camera footage, and post-strike reconnaissance photographs. The scale of destruction was industrial, systematic, and relentless. But numbers do not capture the human experience. The pilots who flew the Thunderbolt in ground attack missions described it as the most intense form of combat they ever experienced. Air-to-air fighting had a certain abstraction. You fought at high altitude, against targets that were distant and impersonal. The ground attack was visceral. You saw the faces of the men you were killing. You saw the trucks explode, the soldiers dive for cover, the buildings collapse. You flew so low that you could read the markings on railway cars, and you knew that every person on the ground with a rifle or a machine gun was trying to kill you. The psychological toll was immense. Pilots flew multiple missions per day, day after day, for months. They watched friends shot down. They returned to base with aircraft so damaged that ground crews shook their heads in disbelief that the plane had stayed in the air. They lived with the knowledge that the next mission might be their last. Some coped by becoming fatalistic. Others developed superstitions, refusing to fly without a particular scarf or photo. Many simply shut down emotionally, completing missions with mechanical efficiency, saving their feelings for later or never. One pilot, interviewed in the 1980s, said that he remembered the sound more than anything. The sound of the R-2800 engine at full throttle was so loud that it drowned out thought. You could not hear the radio, you could not hear the guns firing, you could not hear the flak exploding. You existed in a bubble of noise. Your entire focus narrowed to the gun sight and the target and the pull of G-forces as you hauled the stick back to avoid hitting the ground. He said that for years after the war, he would hear that sound in his dreams, and he would wake up in a cold sweat, convinced he was about to crash. The Germans, for their part, developed a grudging respect for the Thunderbolt. Luftwaffe pilots called it the Indiana, a reference to the American Indian head insignia that many Thunderbolt squadrons painted on their aircraft. In combat reports, German pilots described the Thunderbolt as nearly impossible to shoot down. One report, filed by a Focke-Wulf 190 pilot in August 1944, describes an engagement in which he fired over 200 cannon rounds into a Thunderbolt at close range. The Thunderbolt's engine continued running. The pilot did not bail out. The aircraft simply continued its dive, released its bombs on target, and climbed away. The German pilot concluded that the Thunderbolt must be constructed from some kind of advanced armor that his cannon shells could not penetrate. He was not entirely wrong. The Thunderbolt's durability was legendary. The airframe was massively overbuilt. The wing spars were solid steel. The fuselage structure could withstand G-loads that would have torn apart a lighter aircraft. The radial engine, with its 18 cylinders arranged in a circle, could lose multiple cylinders and still produce power. Liquid-cooled engines, like those used in the Mustang or the Messerschmitt, had a critical vulnerability. A single bullet in the coolant system and the engine would overheat and seize within minutes. The R-2800 had no coolant. It was air-cooled. You could shoot holes through the engine cowling, shatter cylinders, and the engine would keep running, albeit rough and losing power. But running? The armor protection for the pilot was equally comprehensive. Behind the pilot's seat was a sheet of armor plate, 3/8 of an inch thick, angled to deflect rounds coming from behind. The windscreen was layered bulletproof glass, 2 inches thick. The cockpit floor had additional armor to protect against ground fire. A pilot sitting in a Thunderbolt cockpit was surrounded by over 200 pounds of steel and armored glass. This made the aircraft heavier, but it also made the pilot far more likely to survive being hit. The survival rate for Thunderbolt pilots, who were shot down or forced to crash land, was significantly higher than for pilots of other fighters. Many walked away from crashes that should have been fatal. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Robert Johnson's survival on June 26, 1943, became the most famous example of the Thunderbolt's resilience. Johnson, flying with the 61st Fighter Squadron, was escorting bombers over France when his flight was bounced by Focke-Wulf 190s. In the ensuing fight, Johnson became separated from his wingman and was attacked by a German ace, Oberleutnant Egon Meyer. Meyer closed to point-blank range and fired repeated bursts into Johnson's aircraft. The Thunderbolt absorbed over 200 hits. The canopy was shattered. The engine was hit multiple times. The tail was nearly severed. Johnson, wounded and unable to bail out because the canopy was jammed, managed to keep the aircraft flying. He dove for the deck, using the Thunderbolt's superior speed in a dive to escape, and flew the crippled aircraft back across the English Channel. He landed at his base, and when the ground crew examined the aircraft, they could not believe it had stayed in the air. Photographs of Johnson's Thunderbolt, tail number 230505, show a plane that looks like it flew through a storm of shrapnel. Johnson survived without serious injury. He credited the Thunderbolt's armor and construction. He flew combat missions for the rest of the war and ended with 27 confirmed kills. Stories like Johnson's circulated among both Allied and German pilots. For the Americans, they were proof that the Thunderbolt could bring you home. For the Germans, they were deeply unsettling. The psychological impact of fighting an enemy who seemed invulnerable was corrosive. German pilots, already outnumbered and outgunned, began to lose confidence. Morale reports from Luftwaffe units in late 1944 describe widespread fatigue, fear, and a sense of hopelessness. Pilots who survived encounters with Thunderbolts often refused to engage them again unless they had overwhelming numerical superiority. The aircraft had become more than a weapon. It had become a symbol of American material dominance. The industrial capacity behind the Thunderbolt was as important as the aircraft itself. Republic Aviation, at its peak, produced over 1 aircraft per hour. The Farmingdale plant in New York and the Evansville plant in Indiana operated around the clock, employing over 40,000 workers, many of them women. The production line was a marvel of efficiency. Wings were assembled in one section, fuselages in another, engines in a third. The components came together on a moving assembly line, and aircraft rolled out the doors fully assembled and ready for flight testing. From raw materials to finished aircraft took less than 30 days. This meant that losses could be replaced almost immediately. The Luftwaffe, by contrast, was struggling to produce even a few hundred fighters per month by late 1944. German factories were being bombed. Materials were scarce. Skilled labor was being conscripted into the infantry. The disparity in production was as decisive as any battle. The logistical tail supporting the Thunderbolt was equally impressive. Every aircraft required a constant flow of spare parts. Engines needed overhauls every 200 hours. Propellers needed to be replaced. Tires wore out from repeated landings on rough fields. Instruments failed. Radios malfunctioned. Maintaining a squadron of Thunderbolts required a small army of mechanics, armourers, instrument technicians, radio operators, and supply clerks. The U.S. Army Air Forces developed an entire infrastructure to support forward operations. Mobile maintenance units followed the advancing armies, setting up shop in captured towns and abandoned factories. Parts were flown in by C-47 transports. Fuel convoys operated day and night. The system was not perfect. There were shortages and delays, but it worked well enough to keep the Thunderbolts flying, and that was what mattered. The summer and fall of 1944 saw the Thunderbolt reach its apex as a ground attack weapon. The breakout from Normandy, the liberation of Paris, the advance toward the German border, all were supported by relentless air attacks. The Thunderbolts of the 9th Air Force, operating from forward airstrips in France and Belgium, flew close air support missions that redefined what air power could achieve. They worked in coordination with ground controllers, often forward observers riding in jeeps just behind the front lines. The controllers would identify targets, relay coordinates by radio, and within minutes, Thunderbolts would appear overhead, bombing and strafing with pinpoint accuracy. This level of coordination, now standard in modern warfare, was revolutionary in 1944. The German army, already reeling from defeats in Normandy and the Soviet advance in the east, found itself unable to maneuver. Moving in daylight invited immediate air attack. Convoys were destroyed. Supply dumps were bombed. Even individual vehicles were targeted. German soldiers took to moving only at night, hiding in forests and buildings during the day, paralyzed by the constant threat from above. The Wehrmacht's operational flexibility, which had been its greatest strength in the early years of the war, evaporated. The Allied advance accelerated not because of superior tactics or firepower on the ground, but because the Germans could not move fast enough to respond. The Thunderbolt had achieved what strategic bombing had failed to do. It had crippled the German military's ability to fight. By December 1944, as the weather turned cold and the front lines stabilized near the German border, the Luftwaffe attempted one final offensive. The Battle of the Bulge began on December 16th with a massive German counterattack through the Ardennes forest. For the first week, bad weather grounded Allied air power. The Germans advanced rapidly, overrunning American positions and threatening to break through to the coast. The situation was desperate. Then, on December 23rd, the weather cleared. The Thunderbolts returned in force. Over the next 10 days, the 9th Air Force flew over 11,000 sorties. Thunderbolts attacked German tank columns, destroying over 400 armored vehicles. They strafed supply convoys, cutting off fuel and ammunition. They bombed crossroads and bridges, isolating German units. The offensive collapsed. By early January 1945, the Germans were in full retreat, having lost men and equipment they could not replace. The Thunderbolt had, once again, proven decisive. General Eisenhower later wrote that air power had been the critical factor in stopping the German offensive. Without it, he said, the Bulge might have succeeded. The final months of the war saw the Thunderbolt operating in conditions that would have been unimaginable 2 years earlier. By February 1945, Allied forces had crossed the Rhine and were driving deep into Germany itself. The Luftwaffe, once the most formidable air force in the world, had been reduced to scattered remnants. Fuel shortages meant that even the few operational aircraft could barely fly. Experienced pilots were dead or captured. Replacements were boys with less than 50 hours of flight time, sent up in aircraft they barely knew how to control. The skies over Germany belonged entirely to the Allies, and the Thunderbolt ruled those skies with absolute authority. The missions changed in character. There were fewer air-to-air engagements. German fighters rarely appeared, and when they did, they were quickly overwhelmed. Instead, the Thunderbolts focused on what they did best: destruction of infrastructure. Rail yards, bridges, factories, communication centers, anything that kept the German war machine functioning became a target. The attacks were methodical and thorough. Intelligence officers would identify a target, reconnaissance aircraft would photograph it, and then waves of Thunderbolts would strike, often within hours. The German ability to repair damage could not keep pace with the rate of destruction. Bridges stayed down, rail lines remained severed. The industrial heart of the Reich simply stopped beating. The introduction of napalm in early 1945 added another dimension to the Thunderbolt's arsenal. Napalm, a jellied gasoline mixture, was loaded into droppable tanks and used against area targets like fuel depots, supply dumps, and troop concentrations. The effect was devastating. A single napalm strike could create a firestorm that consumed everything within hundreds of yards. Pilots described the sight as both horrifying and mesmerizing. The fuel ignited on impact, spreading liquid fire that clung to surfaces and burned at temperatures exceeding 2,000 degrees. Buildings melted, metal warped. The psychological impact on German troops was profound. Survivors of napalm attacks described a terror unlike anything they had experienced, even in the brutal fighting on the Eastern Front. Yet, even as the Thunderbolt demonstrated its overwhelming destructive power, Questions about its future were already being asked. The jet age had arrived. The Messerschmitt Me-262, though produced in limited numbers and plagued by mechanical problems, had shown that piston engine fighters were obsolete. The Me-262 could fly 100 miles per hour faster than the Thunderbolt. It could climb faster, accelerate faster, and disengage at will. In the few engagements where Thunderbolts encountered 262s in the air, the results were mixed. The jet's speed made it nearly impossible to catch, but its poor maneuverability and limited ammunition meant it could rarely achieve decisive results. Most Me-262s were destroyed on the ground, caught during takeoff or landing when they were vulnerable. The future was clear. Jets would replace propeller-driven fighters. The R-2000 800 engine, magnificent as it was, represented the peak of piston engine technology. There was nowhere left to go. Republic Aviation recognized this and began developing jet fighters even before the war ended. But the Thunderbolt's legacy was secure. It had proven that versatility, durability, and firepower could be combined in a single airframe. The aircraft that followed, from the F-84 Thunderjet to the A-10 Warthog decades later, all carried forward the design philosophy that Alexander Kartveli had pioneered. Build it strong, build it simple, make it survivable. On May 8, 1945, the war in Europe ended. Thunderbolt squadrons, scattered across Germany, France, and Belgium, received the ceasefire order. Pilots who had flown multiple missions per day for months suddenly had nothing to do. The silence was strange. Many described a sense of disorientation, of not knowing what to do with themselves. Some took their aircraft up for joyrides, rolling and diving through the clear spring sky, celebrating their survival. Others simply sat in their cockpits, engines off, trying to process what they had been through. The statistics compiled after the war told a story of overwhelming success. The P-47 Thunderbolt had flown more combat sorties than any other American fighter in the European theatre. It had destroyed more ground targets than any other aircraft. Its loss rate per sortie was among the lowest of any combat aircraft, a testament to its durability and the skill of its pilots. Over 15,000 Thunderbolts were built during the war. They served in every theatre, from Europe to the Pacific to the China-Burma-India theatre. Pilots in every service praised the aircraft. It brought them home. But beyond the numbers, the Thunderbolt represented something larger. It was proof that American industrial power, when fully mobilized, was unstoppable. The Germans had brilliant engineers, experienced pilots, and advanced technology, but they could not compete with an enemy that could produce 15 fighters for every one they built, that could replace losses overnight, that could field aircraft carrying twice the ordnance of anything in the Luftwaffe inventory. The Thunderbolt was not just a weapon. It was a statement, a declaration that the United States had the resources, the ingenuity, and the determination to overwhelm any opponent through sheer material superiority. The human cost, however, should not be forgotten. Thousands of Thunderbolt pilots died in combat. Ground attack flying, for all the aircraft's protection, was brutally dangerous. Many were shot down by anti-aircraft fire. Others died in accidents, misjudging a dive or running out of fuel over enemy territory. Some were captured and spent the remainder of the war in POW camps. Their sacrifice made victory possible. Without the air superiority that the Thunderbolt helped establish, the invasion of Europe would have been far more costly, perhaps impossible. Every bridge destroyed, every rail line severed, every convoy obliterated meant fewer German soldiers at the front, fewer tanks opposing Allied advances, fewer casualties among the infantry pushing into Germany. The pilots who survived carried memories that stayed with them for life. Decades after the war, veterans would gather at reunions, and the conversation would inevitably turn to the Thunderbolt. They would talk about the sound of the engine, the feel of the controls, the sight of tracer rounds arcing up through the darkness. They would remember friends who did not come home. They would describe missions with a precision that suggested the memories were still vivid, still immediate, and they would say, almost, universally, that the Thunderbolt saved their lives, that no matter how badly shot up the aircraft became, it brought them home. That trust, forged in combat, never faded. The aircraft itself largely disappeared after the war. Most were scrapped, cut up for aluminum. A few were sold to foreign air forces and served for years in places like South America and Southeast Asia. Some found their way into private hands and were restored to flying condition. Today, fewer than 50 Thunderbolts remain in existence. A handful still fly, maintained by museums and collectors who understand their historical significance. When one takes off, the sound of that massive radial engine is unmistakable, deep, powerful, authoritative. It is a sound that connects the present to the past, a reminder of a time when the fate of the world hung in the balance, and machines like the Thunderbolt helped tip the scales. The legacy of the P-47 extends beyond aviation history. It influenced the development of close air support doctrine, the integration of air and ground forces, and the design of multi-role combat aircraft. Modern fighter bombers, capable of both air superiority and ground attack missions, are the direct descendants of the Thunderbolt's design philosophy. The lessons learned from operating the aircraft, from logistics to maintenance to tactics, shaped how air forces around the world train and fight. The Thunderbolt was not just a weapon of World War II, it was a template for the future of air warfare. In the end, the story of the P-47 Thunderbolt, carrying 2,500 pounds of bombs and 850 caliber machine guns, is not just a story about technology, it is a story about the people who built it, maintained it, and flew it into combat. It is about the workers in Farmingdale and Evansville, who assembled the aircraft with care and precision. It is about the mechanics who kept them flying through brutal conditions. It is about the pilots who climbed into the cockpit, day after day, knowing that each mission might be their last, and flew anyway because the mission mattered. Their courage, their skill, and their sacrifice turned an improbable design into a legendary weapon. The Germans could not believe what the Thunderbolt could do. By the time they understood, it was too late. The war was already lost. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.